Hi everyone, I am Dr. S, Assistant Professor in Department of Studies and Research in Chemistry, Karnataka State Open University, Muktagangotri, Mysore. In this module, I am going to explain the BSc Chemistry first semesters under the units of Inorganic Chemistry. In your syllabus, they mentioned 4 blocks. Block 1, it is Inorganic Chemistry. Block 2, Physical Chemistry. Block 3, Organic Chemistry. Under that, I am going to handle Unit 1 and Unit 2. Unit 1 and Unit 2. In this Unit 1, just I am going to explain that what is atom, what are the constituent particles of atom, who discovered the atoms, what are the atomic models, Bohr's theory of hydrogen atom, line spectrum of atom, Zeeman effect, quantum number, quantum theory and their significance, shapes of S, P and D orbitals, effective nuclear charge, screening effect, based on that Slater's rule and Pauli's exclusion principles. Here atom means it's a very tiny particles. It is indivisible particles. The fundamental particles of atoms are protons, neutrons and electrons. The proton was discovered by a scientist, Goldstein. Electron was discovered by a J.J. Thomson, and neutron was discovered by a James Chadwick. We consider of this the structure of these atoms. It is in spherical in shape. The center which contains a nucleus. Nucleus it consists of protons plus neutrons. In outermost valence shell, what is that? Electrons are revolving. That's why the nucleus is having a positive charge. Because of this positively charged protons, in neutrons there is no charge. Electron is having a negative charge. Here, due to the electrostatic force of attraction between that nucleus and electron. That electron is revolving around this nucleus to formation of a circular path that is called orbit. Actually, the atomic theory is explained on the basis of Dalton's theory. In that 5th centuries, the Greek philosopher Democritus first expressed the matter consists of very small indivisible particles and he named them atoms. The word atom is derived from that Greek word aromos, which means that uncut or indivisible. It do not undergo further divisible. The very smallest tiny particles, that is called what? Atom. Later that John Dalton extended this idea based on observation. He made and thought that all matter was made of tiny particles called atoms, which he imagined as tiny solids balls. And he gave some postulates or assumptions. Hence, that is the Dalton's atomic theory. According to his, atoms cannot be broken down into anything simpler. The atom of a given elements are identical to each other. The atoms of elements are different from one another. During a chemical reaction, atoms are rearranged to make different substances. Finally, during a chemical reaction, atoms can neither be created nor be destroyed. In 1859, one more scientist, the Julius Fluckers, discovered that cathode rays, while he attempted to pass a high voltage of electric current through gases under reduced pressure, he found that the cathode rays stream from a negative electrode consists of negatively charged particles which travel in a straight lines. These rays gives off flashes of light when they strike on a zinc sulfide coated screen. The cathode rays were later called an electrons by Stoney. In 1897, J. Thomson to determine that mass by charge ratio of an electron. This discovery made a conclusion that electrons are fundamental particles of all types of matter. In 1886, Goldstein, from his experiment, observed that during the formation of cathode rays in an electric discharge tube, one or more electrons are removed from one of the atoms and the positive particles were produced. In 1932, the Chadwick discovered that neutrons particles during his experiment on bombardment of beryllium by alpha particles. When this alpha particle is strike on that beryllium to produce that neutrons. These neutrons have a mass equivalent to proton but without charge. All these experiments provided that the protons, neutrons and electrons are fundamental particles of an atom and were collectively called as subatomic particles. In that table, to summarize that fundamental particles of an atom, the proton, the mass we are expressed in that kg 1.673 into 10 to the power of minus 27 kg. The charge is positive 1.602 into 10 to the power of minus 90. In that neutron, the mass of neutron is almost similar to that protons. 1.657 into 10 to the power of minus 27. In that electrons, a 9.109 into 10 to the power of minus 31 kg. The charge is electron for electron, that is the negative charges here 1.6 into 10 to the power of minus 19 coulomb. Once we discovered that fundamental particles of an atoms like that protons, neutrons and electrons, the challenging job is that how these fundamental particles are distributed in that atoms. Generally we think of that the charge of these protons, neutrons and electrons. Here simply we say that proton is having a positive charges that is present in that nucleus, including neutrons. Neutrons, there is no any charge. Due to the electrostatic force of attraction between that nucleus and outermost valence shell of an electron, the electron is revolving around that nucleus at a certain distance. It creates a path that is called that atoms, just we say that assumption, atoms is having in a spherical in shape. The first theory, it explains that atoms atomic model by a J.J. Thomson atomic model. That J.J. Thomson atomic model is also simply that is called the Flum-Fuding models or Risen-Fuding model. Sometimes it is also called watermelon model also. In this model was proposed by Thomson in 1904 to explain the atomic structure. According to this model, an atom is a uniform sphere of positively electricity of 10 to the power of minus 8 centimeter radius. This is most stable because of this electrostatic arrangement that is shown in that figure 1. In Ziegler and Marsden, in their experiment of scattering of alpha particles directed towards that thin gold foil, observed that some alpha particles were deflected from their straight line path and few were recoiled back towards their source. A uniform sphere of positive charge would mean only a gradual deflection of the alpha particle, but not scattering as it progressed through the foil. Thus, Plum-Pudding model was not able to explain the observations of that Zeeman and Stark, and that is the failure of that what? J.J. Thomson atomic model. There is no any experimental evidences. In that J.J. Thomson atomic model, just we say that the nucleus and outermost valence shell of an electron distance is 10 to the power of minus 8 meter. But there is no any experimental evidence, and it explained only for that nucleus is having a positive charge and electron is having a negative charge, and it is having only electrostatic force of attractions. By consider this aspect of assumptions, this J.J. Thomson atomic model was disqualified to explain that structure of atom. Next, later that Rutherford model to explain that atomic structure. In that Rutherford model, simply there is called the alpha ray scattering experiment. This is the radioactive source. These are all the slates. This is what ZNS screen or gold foil. This is what gold foil. Once this radioactive source is heated, it emits alpha particle. The emitted alpha particle is moved through slit. We observe three types of radiations here. Some of the alpha particle is easily crossed through a gold foil. Some of them is deflected, and some of the alpha particle is rebound. On the basis of this alpha ray scattering experiment, Rutherford in 1911 suggested an atomic model known as a nuclear model, which consisted of nucleus at the center, the negative particles surrounding it has the positive charge and mass of the atom are concentrated in very much smaller space. Hence, nucleus is accounted for mass and positive charge. Just we see that this diagram. Why some of the alpha particle is easily crossed? Because of this. The distance between nucleus and electron was lost. That's why alpha particle is crossed directly. There is no any deflected. Not deflected because more space is in between nucleus and electron. Some of the alpha particles, anyhow this alpha particle is having a positive charges. Nucleus is having a positive charges. When this alpha particle is near to the nucleus, the positive repulsion between that alpha particles and nucleus, that's why alpha particles are deflected. And 1 out of 20,000 alpha particle, 1 out of 20,000 alpha particles is rebound on that same path or same track, because this nucleus is having a mass and it occupies some space. When this alpha particle is directly fall on that nucleus, that is rebounded or reback on the same track. By considering this experimental evidence of this gold-leaf foil experiment or Rutherford model of an atom, the distance between nucleus and electron was empty, means more space is there. Nucleus is having a positive charges, that's why alpha particle is deflected, positive repulsion, and nucleus is have a definite volume because alpha particle is directly falls on that nucleus, that is retract to the same track. This is the conclusions of that Rutherford model. What are the failures of this classical physics? A number of experiments done in later of 19th century and the first 2 decades of the present century gave results totally at variance with predictions of classical physics. Some of the concept is not explained in that classical methods, like black body of radiation, photoelectric effect, heat capacity of variation, atomic spectrum. What is meant by black body of radiation? Black body means an ideal body which absorbs and emits radiation in all frequencies. The radiation is emitted from that body, that is called black body of radiation. The black body of radiation is the radiation emitted by non-reflecting solid body. A perfect black body is one which absorbs all the radiation falling on it. Any radiation that enters through a small opening is reflected repeatedly from the walls until all of the energy eventually becomes absorbed. What are the experimental observations of this black body of radiation? At shorter wavelength regions, intensity of black body of radiation is low. The second thing, at low temperature, black body radiates maximum amount of the particular wavelength, and this wavelength is called lambda max, value of the temperature. At higher temperatures, black body radiates shorter wavelength region with increased the intensity of radiation. For example, a piece of iron heated at 100 degrees Celsius, it becomes hot for that hand to touch, but no visible radiation is observed in this temperature. the shorter the wavelength radiation is emitted by the metal. However, the temperature is progressively increased. First it becomes dull red, then bright red, then orange, finally yellow and white hot. This shows that as the temperature rises, the shorter wavelength radiation is emitted. This is true for all kinds of black bodies. According to this classical theory, the predictions, the black body must radiate over whole wavelength region, including visible region even at room temperature. And also at temperature, black body should emit radiation uniform, more intense. Next thing, heat capacity variation. See, the second drawback of this classical physics is its inadequacy in explaining heat capacity variation with water. This Dulong and Petit, based on their experimental evidences, proposed that the molar heat capacity at constant volume for any metal is equal to 24.93 Joule per mole per Kelvin, and it is independent of temperature. This is called what? Dulong's Petit law. The molar heat capacity is the quantity of heat required to rise the temperature of 1 mole of a substance through 1 degree Kelvin. Experimentally, it is found that lower temperature significant deviation from Dulong and Petit's law was observed. All metals are found to have molar heat capacities lower than 24 Joule per Kelvin. Next, we consider that photoelectric effect. When a metal surface is there, metal surface is made by metal atoms. Metal atom, it consists of nucleus and outermost valence shell of an electron. When a suitable frequency of light is falls on metal surface, the ejection of electrons from the metal surface, that phenomenon is called what? Photoelectric effect. The emission of electrons when metals are irradiated with UV light is known as photoelectric effect. This effect is explained by a scientist like Hertz in 1887. The electrons so emitted are known as photoelectrons. The main features of this phenomenon is that a minimum frequency of light known as that threshold frequency. The minimum frequency of light is required to remove the electron from metal surface, that is what? Threshold frequency. The frequency of incident light is less than this value, the photoelectrons are not emitted. Next, line spectrum of hydrogen. In that line spectrum of hydrogen, when a light is passed through a prism, we are getting different series of lines with different wavelength. When an electron is vaporized and thermally or electrically excited, it emits light. If this light is dispersed, the various wavelengths are separated into different beams by a prism or diffractions grating. The spectrum of this sample is octile. The hydrogen gas gives a series of fine lines of individual wavelength. Is called spectrum of hydrogen atom. Different atoms give different patterns of line spectra at different position. The spectrum of light emitted by excited helium and hydrogen atoms is shown in the figure. This is the line spectrum of hydrogen. The wavelength and wave number of line spectrum of different hybridization is calculated by using the formula. Here mu bar is equal to R 1 by lambda, R into 1 by n1 square minus 1 by n2 square. That is called what? Rydberg equation. With the help of this Rydberg equation, with the help of Rydberg equations, we are going to calculate the wavelength of spectrum lines. So, electromagnetic radiation emitted by free atoms is concentrated at a number of discrete wavelengths. Each kind of atom has its own characteristic spectrum. That is a different set of wavelength at which the lines of the spectrum are found to explain the discrete nature of the spectral lines. In 1913, the Niels Bohr, who working in Rutherford laboratory, developed a new model for the hydrogen atoms by using Planck's and Einstein's ideas or quantized energies. This model provides the satisfactory explanations for the observed line spectra. What are the postulates of this Bohr's theory of these hydrogen atoms? This is an electron in an atom, nucleus, this is electrons. Electron in an atom moves in a definite circular path around the nucleus. This circular path is called orbits. Each orbit has a definite energy and is called an energy shell or energy level. Of all the infinite set of orbits are possible, electrons moves only in those for which its orbital angular momentum is an that integral multiple of h by 2 pi. Electrons moving in such an orbit is in accelerated motion and does not lose energy by electromagnetic radiation. The electromagnetic radiation is emitted if electron initially moving in an orbit with energy EI jumps discontinuously to another orbit of energy EF, and the frequency of emitted radiation is determined by mu is equal to EI minus EF by H, where it is what? Planck's constant. When electron jumps from a higher energy level to lower energy level, it emits energy while it absorbs energy when it jumps from lower energy level to a higher energy level. The energy absorbed or emitted is equal to the difference between the energies of the two energy levels and is determined by Planck's equations. Based on these postulates of Bohr's theory, we can easily calculate the energy of an atomic orbital. Energy of an atomic electron moving in one of the allowed orbits. Bohr assumed that moving electrons in circular orbits around the nuclei experiences by two forces. They are the Coulombic attraction forces between the nuclei and electrons due to opposite charges and centrifugal forces due to circular motion. These two forces are acting opposite to each other and are in equilibrium. An electron of charge E and mass m moving around the nucleus of charge Ze and mass m, the radius or with velocity v. According to that Coulomb's law, the electrical force of attraction is proportional to the product of charge and Z into E and inversely proportional to the square of distance of separation and R square between the nucleus of the and the electron. This is the mathematical expressions of this force of attractions in that nucleus, electron in that nucleus. The term 1 by epsilon 1 by 4 pi epsilon naught is the proportionality constant, and the term epsilon naught is the permittivity in vacuum, and it is equal to 8.854 into 10 to the power of minus 12 Coulomb square per Newton per meter square. When these electrons is revolving around that nucleus, it creates that centrifugal force that is mentioned in that Fc. It is equal to that Fc is equal to mv square by r. These two forces are balancing each other. The force of attraction is equal to the centrifugal force. Both are equating. Finally, mv square is equal to 1 by 4 pi epsilon naught ZE square by R. Rearrange the above equation. What we are getting? Radius. Radius of an orbit is equal to ZE square by 4 pi epsilon naught 1 by mv square. Next we consider that second postulates of this Bohr's atomic theory. The angular momentum is equal to integral multiple of nh by 2 pi. Here velocity is equal to nh by m into r by into 2 pi. The squaring the equations by both sides. The substitutions equations to in equation 1, what we are getting, v square is equal to n square h square by m square into r square by 4 pi square. Multiply equation 6 by m. What is that? M. Equation 6 is multiplied with m only. mv square is equal to n square h square by m r square into 4 pi square. Substitute the value of mv square from equation 3. Here 1 by 4 pi epsilon naught ZE square by r n square h square mr square 4 pi square. Here r is equal to what? N square epsilon naught h square by pi m ZE square. This is what that radius of the Bohr's orbit. What is the energy of an electron in an orbit? The total energy En of an electron in any orbit is the sum of its the potential energy and kinetic energy. The total energy is represented by the sum of the potential energy and kinetic energy. The potential energy is the integration of this force of attraction into dr. We know that Fe value 1 by 4 pi epsilon naught ZE square by r square into dr. Just we are going to take an outside ZE square 4 pi epsilon naught because variability is what? Dr only, that's why 1 by r square. Similarly, the kinetic energy of an electron is given by that mv square by 2. Here mv square by 2 minus ZE square by 4 pi epsilon naught or. Consider that equation 3, what is there? mv square is equal to ZE square by 4 pi epsilon naught r. These are all what that the energy of that electron. Substitute all the constant values in that expressions. 11. What the Z value is 1. Charge of electron is 1.602 into 10 to the power of minus 19. The mass of electron is 9.1 into 10 to the power of minus 31. And 8 is a constant. Finally, what we are getting that energy of the nth orbit is represented by that En is equal to 2.178 into 10 to the power of minus 18 by n square Ksou. For hydrogen atom, Z is equal to 1 and N is equal to 1. Therefore, the energy of the electron is equal to minus 2.178 into 10 to the power of minus 18 Ksou. Here these are all the n values. We are going to substitute here. If n is equal to 1, we are getting these data. If n is equal to 2, 2 square means 4. Same thing, this is the difference in energy between initial and final. From this table, it is clear that the successive energy levels becomes closer. The energy levels are distinctly discrete at lower values of n. As n becomes sufficiently large, the energy levels differ only slightly. This is called the convergence of the energy levels. That Bohr's theory and atomic spectra of hydrogen at. With the help of Bohr's theory, we can calculate the frequencies of spectral lines in the atomic spectra of hydrogen. We derive that expressions of these energies z square e to the power of 4 into m by 8 epsilon naught square h square into 1 by n square. In that n square it is variation. There is no changes the remaining terms here. Only energy level it is changes. That's why we are going to take the common z square e to the power of 4 m by 8 epsilon naught square h square. Thus we are going to take the common factor 1 by n square minus 1 by n2 square. By consider this Planck's constant equation, E is equal to h mu. Here mu is equal to E by h. Just substitute all the values. Finally, we are getting that Rydberg equation. That Rydberg equation is to find the wavelength of spectral lines, where n1 is equal to lower energy level, n2 is equal to higher energy level. By considering this equation, we are going to find the frequencies of spectral lines like Lyman series, Bohr series, Paschen series, Brackett series, and Pfeiffer series, although at the time Bohr formulated his theory. In these slides, we are going to mention only for that Bohr and Paschen series were known that. Just we consider for that n1 values for that Lyman series. This is n2. For that Lyman series, n is equal to 1, n2 is equal to 2, 3, 4 up to infinity. Lyman Bohr series, that Bohr series n1 is equal to 2, here 3, 4, 5 up to infinity. Paschen series, that Paschen series n1 is equal to 3, n2 is equal to 4, 5, 6 up to infinity. That Brackett series 4, 5, 6, 7 up to infinity. Here Pfeiffer series, here n1 is equal to 5, here n2 is equal to 6, 7, 8 up to infinity. When this electron jumps from n2 to n1 is equal to 1, that is first line of Lyman series. Suppose electron jumps from energy level 3 to energy level 1, that is second line of Lyman series. This is the way to calculate the wavelength and frequencies of that hydrogen spectrum. The Zeeman and Stark effect. At the same period when Bohr proposed this atomic theory, the Zeeman and Stark independently the study of effect and electric field of atomic spectra, they discovered peculiar phenomena. In that, Zeeman observed under the influence of external magnetic field lines in atomic spectra, split into a larger number of levels, and each spectral lines are also split in several lines. The splitting is called the Zeeman effect. The same type of splitting or spectral lines was observed by Stark under the influence of an external electric field. The splitting and shifting of spectral lines in the presence of external electric field is called the Stark effect. The Stark effect is an electric analog of the Zeeman effect. What are the limitations of this Bohr's atomic model? Here, Bohr's atomic model theory made correct predictions for smaller sized atoms like hydrogen, which contains uni-electron species. It is failed to explain the Zeeman effect of when the spectral line is split into several components in presence of a magnetic field. And it fails to explain that Stark effect when the spectral line gets split up into lines in the presence of electric field. The next one more theory is there. The refinements of Bohr's atomic theory, simply that is called what? Sommerfeld theory. In order to explain the observed fine structure of spectral lines, the Sommerfeld introduced two main modifications in Bohr's theory. According to Sommerfeld, the path of an electron around a nucleus, both circular or elliptical, with the nucleus at one of its foci. When the path is elliptical, then there are two axes, major axis and minor axis. When length of major and minor axis becomes equal to, then orbit is circular. When that elliptical orbitals are permitted, there are two variable quantities corresponding to varying distance of the electron from the nucleus, varying angular position of the electron with respect to the nucleus, that is azimuthal angle represented by the sign is psi. There are two quantum numbers are introduced to deal these two variables. They are the principal quantum numbers of Bohr's theory, which determines the energy of the electron, and another new quantum number are called orbital. Simply that is azimuthal quantum number or subsidiary quantum number, which has been introduced to characterize the angular momentum of an orbit. Its value vary from 0 into steps of unity. These are all the sublevels, suborbitals. In that first energy level, N1 is equal to 1, N is equal to 1, here L is equal to 0, because L is equal to N minus 1. L is equal to N minus 1. If N is equal to 1, L is equal to 1 minus 1, that value is equal to 0. If N is equal to 2, here L is equal to 1. By considering these N and L values to design the shape of the orbitals, The second energy level n is equal to 2. There are two permeable subshells for the electrons. Here, what is the designation of the shape of this orbital is a spherical in shape. By considering these principal and azimuthal or subsidiary quantum levels, we are going to predict the shape of the atomic orbitals. Like that, s orbital, p orbital, d orbital, etc. Later, we are going to discuss the structure of atoms and orbitals of structure. What are the drawbacks of this Bohr's atomic model? Like Bohr's atomic model, this model does not explain the behavior of systems having more number of electrons. The Sommerfeld modification gave a theoretical background of the fine structure of spectral lines of hydrogen. It could not predict the correct number of observed fine structures of these lines. It could not explain the distribution and arrangement of electrons in atoms. The Sommerfeld model was unable to explain the spectra of alkali metals such as sodium, potassium, etc. It could not explain Zeeman and Stark effect. This model does not give any explanations for the intensities of the spectral lines. Thank you. In next modules, we are going to discuss with that quantum numbers and significance of quantum numbers. Thank you one and all.